Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, I'll talk about basics of VHDL. So we will start with the long form of VHDL to the code structure, how we write code in VHDL, who invented VHDL, which companies use VHDL, what are libraries, what are packages, what is entity, what is architecture. We'll discuss everything in details. And the another videos, the separate video on library and packages, entity and architecture, VHDL operators, data types, data objects, modeling styles are already recorded and they are available on my channel. The links are given in the description box. So here in this video we will start with what is VHDL? So here V stands for very high speed integrated circuits and HDL is hardware description language. So this is hardware description language which describes hardware. It describes hardware means what? It tells us how many inputs and outputs are there, how my hardware works internally. So and this is for very high speed integrated circuits. So VHDL stands for Very High Speed Integrated Circuits Hardware Description Language. The purpose of this language is to describe behavior, how circuit works and its structure, that is what is present inside my circuit. Language style, it is strongly typed. Concurrent language. Concurrent means all statements executes parallelly. See, this language describes hardware. It means when we turn on the switch, whichever components are placed on the board, all of them will turn on simultaneously. It's not like first component will turn on, then second and then third. And that is why to describe hardware, we need a concurrent language. So VHDL is a concurrent language. Then it supports modular design. Modular design means if I have one bulky structure, I can divide it into smaller blocks and I can write code for them. So it is possible to divide the big circuit into smaller circuits. So language style is strongly typed, concurrent, and it supports modular design. Then history of VHDL. Who invented this VHDL? It is developed by US Department of Defense in contribution with Intermetrics, IBM and TI Texas Instruments. It is developed, initiated in 1981 and standardized in 1987. So it is invented by US Department of Defense in 1981. Then it has received a standard IEEE 1076 standard. This language is IEEE 1076 standard in 1987 and again revised in 1993, 2002, 2008 and 2019. It supports both FPGA and ASIC, application specific integrated circuits development. FPGA means programmable logic. We can write one code, we can download that code into FPGA. Then FPGA is volatile. When we turn off the main switch, contents will get erased. Again we can download new code. So it supports both programmable logic design as well as application specific logic design. So VHDL code, when you write your VHDL code, like you people are aware of C language, you enter, you write header files, then you define your inputs at integer, float, or character, main, void main, and in curly brackets, you write your main code. Similarly here, instead of header files, what we have is, we have library and packages. So after that, to define inputs and outputs, to define how many inputs are there, how many outputs are there, we have entity. And in C, what you write is void main and curly brackets and your main code. Here, instead of that, we use architecture. So we explain how our circuit behaves in architecture. Entity only tells us how many inputs are there, what is data type of that inputs. Why data type is important? So that we can apply data in that format. If my input is accepting integer values, I cannot apply 0 and 1 binary values. I must apply some integer number. So entity tells us how many inputs are there, how many outputs are there, what is length of inputs and output, and what data type they support. Architecture tells us how my circuit actually works, and library along with packages stores compiled VHDL code. Package is it consists of the code which we use again and again, like functions, procedures, or data types, data objects, meaning of all keywords, and, or, NAND, NOR. Everything is stored in packages. So this is how VHDL code looks like. It has libraries. So there is not only one library present. The standard libraries are IEEE library, work library, standard library, and also user can define his own library. I have prepared separate video on libraries and packages. There you'll get to know how to create our own library. Everything is explained in details over there. So at the start we must write library. So here I have inserted library IEEE. Use, this use clause is used to insert the package. In upcoming slides also I'll tell you how library works, how package works. So this is library and package where the reusable codes are stored, where compiled codes are stored, meaning of arithmetic operators, logical operators, everything is stored. Then comes entity. Entity tells us how many inputs and outputs are present. So I have written code for AND gate. So entity, name is entity. Oh, sorry, entity, name given to entities and underscore gate. Whenever we write name, or we can assign name to entity, architecture, package, library, it must always start with alphabet followed by numbers, and only one special character is allowed, and that is underscore. So entity in AND gate, there are two inputs A and B, so their direction is in. Then data type is standard logic. The output is Y, its direction is out, and data type is standard logic. Now you may not be aware of data type standard logic. It is just like bit logic, but bit has only two values, 0 or 1, whereas in case of standard logic it has 8 different logical levels, and it is very important to use data type standard logic. See, watch separate video related to data types. The link is given in the description box. It is very important because when we say 0 and 1, logically it is correct, but when we apply 0 volt and 5 volt, so it is not possible that voltage is always 5 volts. Sometimes it may come below 5 volts, sometimes it may go above 5 volt. So we must have some logical levels which will describe those voltages, and for that we use standard logic. And entity name. So this is how we explain how many inputs are there, how many outputs are there, what data type they accept. Then comes actual behavior of our circuit, and architecture does that. So architecture, first word is architecture. Architecture name. So when we write code, or when we write architecture, three modeling styles we use: data flow, behavioral, and structural. So you can assign any name to architecture, but the generally we use modeling styles name as a architecture name of entity name. So I am writing this architecture for this entity, so that I must mention my entity name, so that I will use these data objects A, B, and Y. So here Y, begin, and then Y is assigned as A and B. It means it will AND value of A with value of B. If both are 0, so A and B 0 0, output will be 0. In this way it will assign value to Y. This is called as assignment operator. This arrow is called as assignment operator. And data flow, again I have prepared separate video on assignment operator. You can watch that. See, it is not possible to club everything in single video. That is why I have prepared separate videos on each and every topic. But when you start learning some new language, you must know how its code looks like. What are basic components which we need to know? That you need to know library, you need to know entity, you need to know architecture. And that is why I am creating this video. Okay. So here library and packages in VHDL. So we start our VHDL code with library and packages. So library is a container that stores compiled VHDL design units. So what is library? It is like a container which stores VHDL design units, whereas it is followed by package. So packet is a unit that groups reusable codes like functions. If I need addition function, so it will store that addition function, and whenever we include that package in some other code, that addition code is available to us. Then purpose of library is to organize and manage compiled code modules, and here purpose is to define reusable code that can be shared across designs. So if I'll save one code in package and if I'll include that package, I can use that code. Then it contains, library contains entities, architectures, configurations, packages, etc. Whereas package contains functions, procedures, both are used to write, they are used to, they are subprograms. If functions and procedures are subprograms, we can reuse them again and again. Constants, type, components. To store components or functions or procedures, we use package. Then how to create library? By using vlib, we can create our own library. And when we use that library, we use word library. And package is declared using package and used using use clause. Examples of libraries are library IEEE, library standard, library work, and user defined library. Whereas the examples of packages are, this package is, it belongs to library IEEE. So IEEE dot package name is standard underscore logic underscore 1164. Then work dot my underscore package. So in simple words, these are technical definitions, but in simple words, library is like a folder. You have one folder on your computer and that stores compiled VHDL code. So library stores compiled VHDL codes, whereas package is like one file which is stored in that folder. And it contains reusable code definitions like functions, constants, types. Then comes modeling styles. So see, first part is library, then package, then entity declaration where we declare inputs and outputs. There comes architecture. We can write architecture in different ways and those ways are called as modeling styles. So VHDL supports three modeling styles: data flow, behavioral, structural, and last is fourth one is mixed modeling style. So data flow is, it includes concurrent statements. It means all statements executes parallelly. Behavioral modeling is also called as sequential modeling, and it is used to model sequential circuits. So sequential circuits are where we use memory. Output depends on present input as well as past output, and to store that past output we must need a memory. So whenever we use memory or whenever clock is present in our circuit, then you need to remember that it is sequential circuit, and to model that sequential circuit we use behavioral modeling style. Of course we can model sequential circuits using structural modeling also, but generally we use behavioral modeling style. So when we write code using data flow modeling style, we use either when else and with select statements. When we write code using behavioral modeling, we use if else and case statements. And when we write code using structural modeling, in that case we define components and then we explain how these components are connected with each other. So it is all about modeling styles. Separate video is available. There you will understand. I have taken example of 4:1 multiplexer and I have explained how to write code for that 4:1 multiplexer using data flow, behavioral and structural by using each and every modeling style. There you will understand difference between three of them. Applications of VHDL, where VHDL is used. So see what we started with definition of VHDL, then we discussed about the structure of VHDL code. It contains library, package, entity architecture. So we discussed about packages, libraries, then we discussed about modeling styles which we use in architecture. Now let's see where VHDL is used. So it is used in FPGA configuration for embedded system designs, automotive, defense. Then it is also used in ASIC, application specific integrated circuit design, for high speed, power efficient chips. It is also used in processor and controller design. It is used in communication systems, modems, codecs, transceivers, and digital signal processing for filters, encoders, decoders design. Then which companies use VHDL? So Intel uses VHDL for FPGA and CPU design. Xilinx AMD uses VHDL based Vivado suite. Lattice Semiconductor uses it. Texas Instruments uses VHDL. Synopsys, Cadence, Mentor Graphics, EDA tools using VHDL. They use VHDL language. So thank you so much for watching this video. If you feel this was really helpful, then please subscribe to my channel. Also share this video with your friends and ask them to subscribe, and don't forget to like. If you have any queries, any questions related to this topic or any other topic, just mention it in comment box. I'll prepare video on it. Also don't forget to like, share and subscribe. Thank you so much for watching.